You can take the derivative of a function with respect to another function, but you can't take the derivative of a number with respect to another number. This is because 2 plus 2 is equal to 2 times 2. So let's say that there was this function d that takes in two numbers, x and y, and spits out another number. And we're going to assume that d has some of the properties of the derivative. So the derivative of any number with respect to itself is going to be equal to 1. And then the derivative of y plus z with respect to x is going to be the sum of the derivative of y plus the derivative of z. And the derivative of y times z with respect to some number x would be the derivative of y with respect to x times z plus y times the derivative of z with respect to x. So you maybe want other rules as well, but you would at least want these ones. But from these rules, we can get this contradiction. The derivative of 2 with respect to 2 should be equal to 1, because 2 is equal to 2. But then the derivative of 2 plus 2 with respect to 2 would be the derivative of 2 with respect to 2 plus the derivative of 2 with respect to 2. This is 1 plus 1, which is 2. But then the derivative of 2 times 2, we would use the Leibniz rule, the product rule. And we would get that it is the derivative of 2 times 2 plus the derivative of 2 times 2. But the derivative of 2 with respect to 2 is 1, so this is 2 plus 2, which is equal to 4. And so, what have we proved? We've shown that the derivative of 4 with respect to 2 is equal to 2, and the derivative of 4 with respect to 2 is 4. So 2 is equal to 4, which is a contradiction. So if we have a collection of objects n, and we can add them, we can multiply them, then we've shown that there can't be a d that takes in two n's and outputs another n, such that the derivative of x with respect to x is 1, and we have a version of an equation representing the sum rule and an equation representing the product rule. And so for a similar reason, you can sort of use the same argument to show that any differentiable function, something that you can differentiate, if f plus f is equal to f times f, so if f acts kind of like 2, then that function has to be a constant. Because otherwise, the derivative of f plus f with respect to f would be different from the derivative you get using the product rule of f times f with respect to f. And so this would be a contradiction. So this means that any differentiable function that has this property, f plus f equals f times f, has to be constant. It has to be either 0 or 2.